Hi, we are from Group 3 Section 4. We'll present about our hydrology report. Before that, I will introduce my group member. First, Husna Hanina binti S. Muhammad Rafi. Second, Izzati Shazwani binti Abdul Halim. And third, Khadijah binti Muhammad Ali. And I'm Haikal anak lelaki Hadi. First of all, I will present about our introduction for our project report, Threat of Flooding. Significant global threat causing damage to property, infrastructure and the environment. Effective flood management is crucial to mitigate impacts and enhance resilience. Report focus. Our report focus at key aspect of flood routing, application of the HEC-RES modeling tool, design of a flood mitigation pond. Flood routing. Predict and analyze flood water movement through river and reservoir, essential for anticipating peak flow and timing. Vital for designing effective flood mitigation structure. HEC-RES modeling tool. Provide detailed simulation of river hydraulic and flood behavior. Offer valuable insight into flow pattern and water surface profile. Crucial to accurate flood risk assessment and management. Flood mitigation pond design. Based on flood routing analysis and HEC-RES modeling result, temporarily stores excess runoff during peak flow and release it gradually. Aim to reduce downstream flood risk. Propose pond shape tailored to address specific flood challenge in a particular area. And the last, enhance community flood resilience through a comprehensive approach. Second part, I will present about our objective. First, understanding flood routing. Analyze the movement and distribution of flood water through river channel and reservoir to improve flood risk management. Second, understanding HEC-RES modeling. Utilize the HEC-RES tool to simulate river hydraulic and accurate assess flood risk. Third, propose a sustainable pond shape. Design an optimal pond shape that enhance flood water storage and efficient release, informed by insight from flood routing and HEC-RES modeling. Design a flood mitigation pond. Develop a detailed design for a flood mitigation pond that effectively store excess runoff during peak flow period and release it gradually to reduce downstream flooding. And the last, propose a specific flood mitigation pond. Create a tailored design for a flood mitigation pond aimed to reducing flood occurrence in a particular area, thereby enhancing the community flood resilience.
During this project, the activities that we do is meeting to WhatsApp group chat, where we assign tasks to each of team members. The second one is we have online discussion to update the project progress. And then process of learning HEC-RES, where we learn the HEC-RES by referring the video given on YouTube. And then we install HEC-RES. After that, we start the project using the given data. And then we identify the flood condition by seeing the geomatics and flow condition. And then we propose pond using HEC-RES. And then we have terrain modification, geometric modification, plan unstudied flow analysis, and run and view results. And then we repeat the step until solve the downstream flood.
Next is result and discussion part. As you can see, these are the images of before and after flood mitigation pond. For before flood mitigation pond, many areas have been flooded. And after flood mitigation pond, the flooded areas are no longer flooded because the water flows into the pond. Here are the discussion part. The initial image shows a topographical map with extensive flooding across multiple regions. The blue shaded areas signify significant water accumulation indicating widespread inundation likely caused by heavy rainfall. This flooding can result in considerable disruptions, including infrastructure damage, displacement of residents, and economic losses. The severity of the flooding highlights the need for effective flood management solutions to mitigate these adverse impacts. The second image offers a stark contrast depicting the same region after the construction of the flood mitigation pond. The significant reduction in blue shaded areas indicate that the pond effectively captures and contains the excess water, preventing it from spreading across the landscape. The flood mitigation pond provides several benefits, including reduction in flooding, improved water management, enhanced safety, environmental benefits, and economic savings. By capturing excess runoff, the pond prevents water from inundating residential and commercial areas. It also helps regulate water flow, ensuring that downstream areas are less likely to experience sudden surges in water levels.
Next, the implication of the project. The first one is enhance flood risk management by accurately stimulating flood flows and inundation extent. HECRAS help in identifying high-risk areas and formulating effective mitigation strategies. This lead to enhanced flood risk management and reduce vulnerability in communities and infrastructure. The second one is environmental impact assessment. The project allows for assessing the potential environmental impacts of floods and hydraulic structure on ecosystem, habitats, and water quality. This ensures the flood management strategies are sustainable and minimize adverse environmental effects. For the third one is city planning and development. City planners can use HECRAS outputs to inform land use decision, zoning regulation, and infrastructure investments. This promotes sustainable development practice that consider flood risk and resilience measures. For the fourth one is enhanced infrastructure design. Engineers can use HECRAS output to design and retrofit hydraulic structure such as bridges, culverts, and lifts to better withstand flood events. This improves the resilience of infrastructure and reduce damage during floods.
5. Regulatory compliance. Governments and agencies can use HECRAS results to ensure compliance with regulations related to floodplain management, environmental protection, and public safety. This includes adhering to floodplain development regulations and designing structures that meet safety standards. 6. HECRAS can be used for public safety and awareness. Communities benefit from improved flood forecasting and early warning systems based on HECRAS simulations. This enhances public safety by providing time alerts and evacuation advisories, thereby reducing the risk to lives and properties. 7. Emergency response planning. Accurate flood modeling with HECRAS supports emergency response planning by providing timely information on flood extents, depths, velocities, and potential impacts. This aids in evacuation, planning, resource allocation, and coordination of response efforts during flood events. 8. Economic benefits. Effective flood management through HECRAS can result in cost savings associated with reduced flood damage to property and infrastructure. It also supports economic stability by minimizing disruption to businesses and livelihoods during flood events. Conclusion. In conclusion, the utilization of HECRAS for flood rating presents an array of significant benefits and implications across multiple critical areas of flood management and infrastructure development. By accurately simulating flood flows and predicting inundation extents, HECRAS enhance flood risk management strategies, enabling proactive measures to safeguard communities and infrastructure. Moreover, it supports precise infrastructure design, ensuring that hydraulic structures like bridges, culverts, and levees are robustly engineered to withstand potential flood impacts. Recommendations. Looking ahead, continuous advancements in HECRAS modeling techniques are crucial for integrating real-time data effectively, enhancing the accuracy of flood forecasting, and supporting adaptive management strategies in flood-prone regions. The ongoing development of hackers should prioritize advancement in computational methods, remote sensing technologies, and data assimilation techniques to improve the reliability and responsiveness of flood predictions. By leveraging these innovations, stakeholders can make informed decisions swiftly, mitigating potential damage and apa susah